Let me ask you something. What happens when you walk across a room? You put one foot in front of the other. Your body moves. The air parts around your face, your heart beats, your blood moves through your veins. Nothing strange, nothing unusual. Just a person walking. Now, what if you walk faster? What if you jog? What if you sprint? You breathe harder. Your muscles burn. Your feet hit the ground with more force. But fundamentally, nothing weird happens. You are still you. Your watch still ticks. Your bones are still solid. Your eyes still work. Everything is normal. So let me ask the next question, the obvious question, the question that sounds so innocent you would never suspect it could ruin your afternoon. What if you go faster? Much faster. Unimaginably faster. What if you could move at the speed of light, 186,000 miles every second? What would happen to your body? And I am not asking what it would feel like. I am asking what the physics actually says would happen. That to your flesh, to your bones, to your atoms, to time itself inside you. Because the answer is not what you think. The answer is deeply, profoundly strange. And if you follow me through this carefully, step by step, you are going to arrive somewhere you did not expect. Somewhere that might genuinely disturb you. But we start simple. We start with a ball. Suppose I throw a ball across this room. It leaves my hand at, say, 20 miles per hour. Now you are riding in a car going 60 miles per hour, and I throw the ball forward out the window. How fast is the ball going relative to the road? 80 miles per hour. 20 plus 60. Simple addition. Every kid knows this. This is called Galilean relativity. Velocities add. It is common sense. It is obvious. It works perfectly for everything you encounter in daily life. For baseballs and cars and airplanes and even rockets. For 300 years, nobody had any reason to question it. It was just how the world worked. Then along comes light. And light does not play by the rules. In the 1800s, a fellow named James Clerk Maxwell sits down and writes 4 equations that describe electricity and magnetism. These are not simple equations, mind you. They took decades of experimental work from Faraday and Ampere and Gauss and others to build up to, but Maxwell writes them down and he notices something remarkable. Hidden inside them, like a secret message folded into the mathematics, is a speed, a very specific speed, the speed at which electromagnetic waves, which includes light, must travel. And when you calculate that number, you get about 186,000 miles per second. But here's the part that made people nervous. That number does not depend on anything. It does not care how fast the source is moving. It does not care how fast the observer is moving. It does not care what direction you are facing or whether you are on a train or on the moon. The speed of light comes out of the equations as a fundamental constant. Fixed, universal, non-negotiable. Think about how completely insane that is. If I am standing still and I shine a flashlight, the light goes at 186,000 miles per second. Fine. Now I get in a spaceship going 99% the speed of light, and I shine the same flashlight forward. How fast does the light go relative to someone watching me fly by? Your gut says, add them up, 99% of c plus c, nearly 2c. That is what Galileo would say. That is what Newton would say. That is what every piece of common sense in your body screams at you. But the universe says no. The light still goes at exactly 186,000 miles per second. The same speed, unchanged, unmoved, as if the motion of the spaceship did not matter at all. This was the bombshell. This was the crack in the foundation. And the man who took that crack and rebuilt all of physics around it was Albert Einstein in 1905 with his theory of special relativity. Einstein did not discover that the speed of light was constant. Maxwell's equations already said that. Michelson and Morley had already failed to measure any variation in it. What Einstein did was take that fact seriously. He said if the speed of light is truly the same for all observers, then space and time themselves must bend to make it so. And he worked out exactly how they bend. So how does the universe enforce its speed limit? What does it actually do to keep light always moving at the same speed for everybody? It changes the fabric of reality. It warps time. It warps space. It makes the stage itself flexible. Let me show you the first thing it changes. Imagine you have a clock, a special clock, very simple. 2 mirrors facing each other with a single photon of light bouncing back and forth between them. Every time the photon hits the bottom mirror, the clock goes tick, one bounce, one tick. Very precise, no gears, no springs, no batteries. Just light and mirrors. Now you are standing on the ground watching me fly past you in a spaceship at tremendous speed, and I have this light clock mounted on the wall of my ship. The mirrors are arranged vertically, one above the other. From my perspective, inside the ship, the photon is bouncing straight up and down. Simple, the path is short, the ticks are quick. But from your perspective, watching me zoom past, something different is happening. The ship is moving sideways while the photon is bouncing. So the photon, as you see it, is not going straight up and down. It is going diagonally, like a ball bouncing inside a moving train. It traces a zigzag path through space. The diagonal path is longer than the straight up and down path. That is just geometry, Pythagorean theorem. But here is the key. The speed of light is the same for you as it is for me. The photon cannot speed up to cover the longer diagonal path in the same amount of time. It is stuck at c. So what happens? It takes longer. Each tick of my clock, as seen by you, takes more time. My clock is running slow. This is time dilation. And I need you to understand something crucial about it. This is not an illusion. This is not a trick of perception. This is not like how a distant clock looks small, because it is far away. My clock is genuinely, physically, actually running slower. Every clock on my ship runs slower. Every oscillation of every atom runs slower. My heartbeat runs slower. The chemical reactions in my cells run slower. The electrical signals in my brain run slower. The radioactive decay of potassium in my bones runs slower. Everything, all of it, slower. How much slower? That depends on how fast I am going, and the answer is governed by a single number that is going to haunt the rest of this lecture. That number is called gamma. Gamma equals 1 divided by the square root of 1 minus v squared over c squared. V is how fast you are going. C is the speed of light. Do not worry about the formula. Worry about what it does. When you are sitting still, A is 0, and gamma equals 1. Time flows normally. Everything is fine. At 10% of the speed of light, gamma is about 1.005. The time dilation is 0.5%. You would never notice. At 50% of the speed of light, gamma is about 1.15. Your clock runs about 15% slower compared to someone standing still. Noticeable if you measure carefully, but not dramatic. At 80%, gamma is about 1.67. Your seconds are almost 70% longer than normal seconds. Now it matters. At 90%, gamma jumps to about 2.3. Your clock runs at less than half the normal rate. For every second that passes on your ship, more than 2 seconds pass on Earth. You are living in slow motion, and you do not even know it. At 99%, gamma is 7.1. A week on your ship is 7 weeks on Earth. A year on your ship is 7 years back home. You leave on a trip. You come back. Your children have aged. You have not. 99.9%. Gamma is 22.4. A year for you is 22 years for everybody else. 99.99%. Gamma is about 71. A year for you is a human lifetime for someone who stayed behind. You see the pattern? Gamma does not grow gently. It does not increase in a nice steady way. It explodes. It goes vertical. As you get closer and closer to the speed of light, gamma races toward infinity like a car accelerating off a cliff. And at exactly the speed of light, gamma is infinite. Truly infinite. 1 divided by the square root of 1 minus 1, which is 1 divided by 0, which is infinity. Infinite time dilation means time stops, not slows. Stops. A clock moving at the speed of light does not tick. Not slowly. Not once in a billion years. Not once in the lifetime of the universe. Never. It is frozen in a single instant that does not pass. If your body were traveling at the speed of light, your heart would not beat. Your neurons would not fire. Your blood would not flow. Not because something is restraining them. Not because some force is holding them still. But because time itself, the thing that allows one moment to follow another, the thing that allows change to exist, that thing is gone. There is no next moment. There is no sequence of events. There is only a single eternal frozen now. Already you should be uncomfortable. But we have only talked about time. Let me show you what happens to space. There is a companion effect to time dilation. Its name is length contraction. When an object moves very fast, it becomes shorter in the direction of motion. Not because something is compressing it, not because the atoms are being squeezed together by some force. The physical space between the front and back of the object, the actual distance, shrinks. The geometry of reality itself is changing. This was one of the strangest predictions when it was first proposed. Hendrik Lorentz and George Fitzgerald, working independently in the 1890s, suggested that objects literally contract when they move. At the time, people thought it might be some kind of mechanical compression, as if the aether wind were physically pushing objects together. Einstein showed it was nothing of the sort. It is a consequence of how space and time relate to each other, not a force, a geometry. At 50% of the speed of light, an object is about 87% of its rest length. Hard to notice. At 90%, it is about 44%. A 6-foot person measured in the direction of motion would be about 2 feet 8 inches from front to back. Imagine that. You look normal from the side, but from the front, you are compressed, flattened, squished into something uncanny. At 99%, about 14%, you are a thin slab, a pancake of a person. At 99.9%, about 4.5%, an inch or two thick. And at the speed of light, 0. Your length in the direction of motion is 0. Not very small, not microscopic, 0. You have no spatial extent whatsoever in the direction you are traveling. You have been compressed into a two-dimensional surface, an infinitely thin sheet. Combine this with the time dilation. At the speed of light, you have no thickness and no duration. You are not a three-dimensional object moving through time. You are a flat, frozen, timeless thing. A mathematical surface sliding through space at sea with nothing inside it happening, nothing changing, nothing occurring. I want you to sit with that image for a moment before I make it worse. Let me talk about energy. When you push something to make it go faster, you are putting energy into it. This is basic. You push a cart, the cart speeds up. You did work on it. The energy of the cart went up. In Newtonian physics, the energy of motion is 1/2 times the mass times the velocity squared. Double the speed, quadruple the energy. Simple, but special relativity changes this. The total energy of a moving object is gamma times m times c squared. That gamma again, as your speed increases, gamma increases and the energy increases, but not in the nice quadratic way Newton described. In the monstrous, exploding, approaching infinity way that gamma behaves near c. Let me put numbers to this. Suppose you have a 1 kilogram object. At rest, its energy is mc squared, which works out to about 90 million joules. That is the energy content of its mass, the famous rest energy, enough to level a city. Now accelerate it to 10% of the speed of light. The kinetic energy is small compared to the rest energy. Nothing dramatic, accelerate it to 50%. The total energy is now about 15% more than the rest energy. Significant but manageable. At 90%, the total energy is 2.3 times the rest energy. You have more than doubled the energy budget. At 99%, 7 times the rest energy. That is an astonishing amount of energy invested in motion. At 99.9%, 22 times the rest energy. To reach the speed of light itself, the energy required is infinite. Not just very large, not merely astronomical, infinite. You would need more energy than exists in the entire observable universe. More than the output of every star that has ever shone, combined for all of time. It is not enough. It will never be enough. The mathematics does not care about your ambition. It says you cannot do this, and it means it. Let me give you a sense of scale here. A single human body has a mass of about 70 kilograms. The rest energy of that body, the famous mc squared, is about 6.3 times 10 to the 18th joules. That is roughly the energy released by 150 million tons of dynamite. Just by existing, your mass contains the energy equivalent of a catastrophic bomb. That is the energy you start with, before you even move. To accelerate that body to 99% of the speed of light, you need to add about 6 times that rest energy. You need the energy of roughly 1 billion tons of dynamite just for the kinetic energy alone. To go from 99 to 99.9% costs more energy than going from 0 to 99. To go from 99.9 to 99.99 costs more still. Each additional 9 on the speedometer costs more than all the previous 9s combined. The universe is essentially saying, you want to get close to my speed limit? Fine, but I am going to make each step more expensive than the last. And the final step, the step from almost C to exactly C, costs more than everything. It costs infinity. People sometimes describe this as the object getting heavier. That is an older way of talking about it, and modern physicists tend to avoid the phrase because it creates confusion about what mass means. But the intuition is not entirely wrong. The resistance to further acceleration increases. You are pushing, and the universe is pushing back, and the harder you push, the harder it pushes, as if the object is getting more and more stubborn, more and more reluctant, more and more deeply rooted in its refusal to reach C. This is why nothing with mass has ever traveled at the speed of light, and nothing ever will. It is not a technological limitation. It is a structural feature of space-time itself. The universe is built in such a way that the speed of light is a wall, not a finish line. But forget the impossibility for a moment. I want to ask what happens to your body on the approach, because the approach, long before you hit C, is where the real nightmare begins. Your body is made of roughly 7 billion atoms. Those atoms are arranged into molecules, and those molecules are arranged into cells, and those cells are organized into tissues and organs and systems that keep you alive. All of this is held together by electromagnetic forces. All of it functions because electrical and chemical signals can travel from one part of your body to another in a timely fashion. Your biology runs on communication, on timing, on sequence. And as you accelerate toward the speed of light, the universe starts to assault you. Consider the cosmic microwave background radiation. Right now, all around you, filling the entire universe, there is a faint glow of electromagnetic radiation left over from the Big Bang. It has been traveling through space for about 13.8 billion years, stretching and cooling as the universe expands. Until now, it has a temperature of about 2.7 degrees above absolute zero. Its photons are in the microwave range with wavelengths of about a millimeter. They are everywhere. Billions of them pass through your body every second. They are utterly harmless. You cannot feel them, see them, or detect them without specialized equipment. But if you are moving at extreme speed, those photons are no longer harmless. The Doppler effect, you know this from ambulance sirens. When an ambulance is coming toward you, the pitch is higher. When it is moving away, the pitch is lower. The same thing happens with light. Photons coming toward you from ahead get compressed, blueshifted, their wavelengths shortened, and their frequency increased. Photons coming from behind get stretched, redshifted. So imagine you are accelerating. You feel fine, the ship hums, the stars look normal. But as your speedometer creeps past 90% of science, something strange happens. A faint warmth on your face, coming from nowhere. Those microwave photons from ahead have been blue-shifted into the far infrared, and your skin is absorbing them as gentle heat. Odd, but not alarming. You keep accelerating, past 99%. The warmth brightens, the void ahead of you begins to glow. Not starlight, something softer, stranger. You are seeing the cosmic background radiation with your naked eyes. The oldest light in the universe, 13 billion years old, compressed into visible wavelengths by your own velocity. Space itself is luminous. It is beautiful, for about 3 seconds. Because as the engines push you past 99.9%, that glow shifts from white to violet to invisible. The photons are now ultraviolet. Your skin reddens. Your corneas sting. The afterglow of creation is giving you the worst sunburn in history, and it is getting worse by the millisecond. 99.99. The photons have crossed into the X-ray band. They slice through your skin like it is not there. They ionize atoms in your marrow. They snap DNA strands faster than any repair enzyme can stitch them back together. One more 9. 99.99. Gamma rays. Every photon from the cosmic background now carries the energy of a particle spat out by a nuclear reaction. You are not just being irradiated, you are being erased, layer by layer, by what was, just moments ago in the universe's frame, the weakest and most harmless radiation in existence. And it gets worse. The cosmic microwave background is not the only source of photons in the universe. There is starlight, there is infrared radiation from dust and gas. There are radio waves from pulsars and galaxies. All of it, everything coming at you from the forward hemisphere, gets blue-shifted. At high enough speeds, ordinary starlight becomes X-ray bombardment. Radio waves become ultraviolet. The entire forward sky becomes a focused beam of lethal energy. Meanwhile, everything behind you redshifts into oblivion. The stars behind you fade to infrared, to microwave, to radio, to nothing. The sky behind you goes dark, the universe narrows to a single blazing point of light ahead of you, surrounded by blackness. This is called relativistic beaming. All the light in the universe from your perspective is being funneled into a cone in front of you, and that cone is getting narrower and brighter and more lethal with every incremental increase in speed. Your body, a fragile architecture of carbon-based molecules evolved to survive in a narrow band of temperatures and radiation levels, is being pummeled by the concentrated electromagnetic energy of the cosmos. And you are not even at the speed of light yet. You are just very, very close. But let me ask a question from the other side. Forget what an outside observer sees. What do you see? What does the universe look like from the cockpit of this impossible ship? Because your experience, if you could survive the radiation for a moment, would be extraordinary and terrifying in equal measure. At modest speeds, say 10 or 20% of C, you would notice almost nothing different. Stars ahead look slightly bluer. Stars behind look slightly redder. Subtle. You need instruments to measure it. At 50%, the distortion becomes visible. The stars ahead of you are noticeably bluer and brighter. The stars behind you are dimmer and redder. The familiar constellations start to look wrong. Orion's belt is shifting. The Big Dipper is warping. The geometry of the sky is changing, as if someone is pulling the stars forward like beads on a rubber sheet. At 90%, the effect is dramatic. Most of the stars in the sky have migrated to the forward hemisphere. The sky behind you is almost empty, dark. The stars that remain back there have redshifted into invisibility. Ahead of you, the sky is crowded and brilliant, like looking at a galaxy through a magnifying glass. At 99%, almost all of the light in the universe is concentrated in a small, searing disk directly ahead of you. The rest of the sky is black. Completely, absolutely black. Not the darkness of night, the darkness of a universe that has been swept clean of photons in every direction except one. You are flying into a spotlight, and the spotlight is the entire cosmos, compressed and concentrated by your velocity into a tiny burning point. This is relativistic aberration. It is a real optical effect derivable directly from the Lorentz transformations. And it means that as you approach the speed of light, the universe itself appears to collapse in front of you. Space shrinks ahead. The stars crowd together. Everything you could possibly see is crammed into an ever-shrinking circle of blazing light, dead ahead. If you turned around and looked backward, there would be nothing. Absolute void. Not because the universe behind you has disappeared, but because every photon from that direction has been redshifted to wavelengths so long that no detector, no eye, no instrument could ever register them. The universe behind you still exists. You just can never see it again. Meanwhile, your body is being ripped apart at the molecular level. Let me be specific about this because the details matter. Your DNA is a long, twisted molecule. It encodes the instructions for building and maintaining you. It is fragile. Ultraviolet light can break it. A single X-ray photon can snap it in two. Your cells have repair mechanisms that fix DNA damage all the time. You get thousands of DNA breaks every single day just from normal thermal fluctuations and background radiation, and your body patches most of them up. But at 99.99% of the speed of light, you are being hit by a flood of X-ray and gamma-ray photons from ahead. Not thousands of breaks per day, millions per second, hundreds of millions. Your repair mechanisms are overwhelmed in nanoseconds. The damage cascades. Proteins unfold. Cell membranes rupture. Water molecules in your tissue are ionized, creating free radicals that tear through surrounding structures like shrapnel. The orderly biochemistry that keeps you alive dissolves into chaos. Your brain, which runs on delicate electrochemical gradients maintained across membranes only a few nanometers thick, would be among the first organs to fail. Those membranes depend on precise molecular arrangements. Gamma radiation does not care about precise arrangements. It smashes through them like a bowling ball through a house of cards. And none of this even accounts for the thermal effects. When you absorb that much electromagnetic radiation, the energy has to go somewhere. It goes into heat. Your body temperature rises, not gradually like a fever, explosively like a microwave oven with no off switch. The water in your cells boils. Your tissues cook, from the front backward, layer by layer. Your body is converted from a living organism into an expanding cloud of superheated plasma. All of this, remember, from photons that started out as the cosmic microwave background, the coldest, weakest, most benign radiation in existence, turned lethal by nothing more than your own velocity. I want to step back from the violence for a moment and talk about something more subtle. Something that I think is actually more disturbing than the radiation, if you think about it long enough. When we talk about objects moving through space, we picture them as things at a location, progressing from one place to another through time. That is the Newtonian picture. That is how your brain models reality, because your brain evolved in a world where nothing moves very fast, and this picture works beautifully for everything in ordinary experience. But Einstein showed us something different. Something that still makes my head spin a little, if I am honest. Space and time are not separate things. They are two aspects of a single four-dimensional continuum called spacetime, and your motion through spacetime is always at the same total speed. Always, for everything, without exception. Right now, sitting in your chair doing absolutely nothing, you are hurtling through spacetime at the speed of light. All of your spacetime speed is directed through the time dimension. You are racing through time at the maximum possible rate. And that is what being at rest means. Not that you are motionless in spacetime. You are never motionless in spacetime. It means all your velocity is pointed in the time direction. When you start moving through space, something has to give. Your total spacetime speed is fixed at c. You cannot exceed it. So when you allocate some speed to the spatial dimensions, you must subtract it from the time dimension. You trade temporal velocity for spatial velocity. Move through space at a walking pace, you lose an imperceptibly tiny sliver of your time speed. You age a trillionth of a second slower than someone sitting still. Real but unmeasurable. Move through space at 90% of c. You have diverted so much of your space-time velocity into the space direction that your time velocity has dropped to about 44% of its rest value. You are moving through time at less than half the normal rate. Move through space at the speed of light. All of your space-time velocity is allocated to space. There is nothing left for time. Zero. Your velocity through time is zero. Time has stopped. This is the deepest, clearest, most elegant way to understand time dilation. It is not some exotic relativistic side effect. It is bookkeeping. You have a speed budget. It is always c, divided however you want between space and time. But the total is fixed, and this means that light itself, photons, which travel at c through space, have zero velocity through time. A photon does not experience time. It does not age. From its own perspective, if we can use that phrase without being too loose, a photon is created and absorbed in the same instant. A photon emitted by a star 100 million light-years away arrives at your eye, and for that photon no time has passed. None. The 100-million-year journey took 0 seconds of photon time. The departure and the arrival are the same event. Now transfer that understanding to a human body at the speed of light. If all your space-time velocity is in the spatial direction, you have no motion through time. Your internal processes do not unfold. They cannot unfold. There is no time for them to unfold. And your consciousness, which is a sequence of electrochemical events in your brain, requires time in the same way that a song requires time. You cannot play a song in 0 seconds. You cannot have a thought in 0 seconds. You cannot experience anything in 0 seconds. Not darkness, not stillness, not the passage of nothing. You cannot even experience the absence of experience, because that itself would be an experience, and experiences require duration. And there is another dimension to this that most people miss. It is not just time that vanishes. Remember length contraction? At the speed of light, your length in the direction of motion contracts to 0. But length contraction does not just apply to you. It applies to everything in the direction you are moving. The entire universe, measured along your direction of travel, contracts at 90% of SIR. A 10 light-year distance shrinks to about 4.4 light-years. You can cross it faster because the distance is genuinely shorter in your frame. At 99%, that 10 light-year distance is only about 1.4 light-years. At 99.999%, it is about 0.04 light-years. A 10 light-year journey has become a trip of a few light days. And at exactly the speed of light, the distance is 0, not approximately 0, exactly 0. The distance between you and any object in the direction of your motion whether it is the next room or the Andromeda Galaxy or the most distant quasar at the edge of the observable universe, is zero. It is all right here, right where you are. A photon traveling from a star in Andromeda to your retina crosses 2.5 million light-years in our frame. But from the photon's perspective, the distance is zero. The star and your eye are in the same place. No travel occurs. No journey is undertaken. Emission and absorption are the same event at the same location at the same non-time. If your body were at sea, the entire universe in your direction of motion would be compressed into a single plane, everything in front of you and everything behind you, all squeezed into a two-dimensional sheet of zero thickness. You are not traveling through the universe. The universe has been folded up into a point that you already occupy. A journey of 1 billion light-years takes zero time and covers zero distance. Because from your frame there is zero time and zero distance to cover, I want you to really feel the weight of that. You did not travel fast. The universe got small, and if the universe is zero distance in your direction of motion, the concept of going somewhere has lost all meaning. You are already everywhere along your line of flight, and you are already every when, because there is no when. What you would be in that state is a question that physics alone cannot answer. The atoms are there, the information is there, but process requires time, and you have none. You are a book with all its pages pressed together into a single sheet. Every word is technically present, but no one can read it. Not even the book itself. I find that thought genuinely haunting. Not frightening exactly. Haunting. Like a house that is perfectly intact, but will never have anyone living in it again. Let me bring this back to Earth with some evidence. Because everything I have been describing is not theoretical speculation. It is confirmed physics. Muons. Beautiful, tragic, perfect little particles. A muon is created when a cosmic ray, usually a very high-energy proton from somewhere in the galaxy, slams into the upper atmosphere and creates a shower of particles. One of those particles is a muon. It is like a heavy electron. It is unstable, it decays. Its half-life is about 2.2 microseconds. That is 2 millionths of a second. Muons are created at the top of the atmosphere, roughly 10 miles up, even traveling at the speed of light. A muon with a 2.2 microsecond lifetime should only make it about 2,000 feet before decaying. It should never reach the ground. The math is simple, and the answer is clear. But muons reach the ground. We detect them all the time. Every square meter of the Earth's surface is hit by about 10,000 muons every minute. They are coming from 60,000 feet up, and they are arriving at sea level, and they should not be able to do that. Time dilation is the answer. Those muons are traveling at about 99.95% of the speed of light. Their gamma factor is about 31. From our perspective, their internal clock is running 31 times slower than normal. Their 2.2 microsecond lifetime stretches to about 68 microseconds. That is enough time to travel the full distance to the ground. And from the muon's perspective, length contraction. The muon sees the atmosphere contracted by a factor of 31. The 10-mile distance to the ground is only about 1/3 of a mile in the muon's reference frame. It easily covers that distance in its 2.2 microsecond lifetime. Both perspectives agree. The muon reaches the ground, but they explain it differently. In our frame, the muon lives longer. In the muon's frame, the atmosphere is shorter. Both are correct. Both are real. The physics is consistent. This is not an interpretation. This is a measurement. We have verified time dilation and length contraction thousands of times in cosmic ray experiments and particle accelerators, in precision atomic clocks flown on airplanes and satellites. GPS satellites, which orbit the Earth at relatively modest speeds, have their clocks adjusted for relativistic time dilation. If they did not make that correction, your GPS position would drift by about 6 miles every day. So when I tell you that your body at the speed of light would have its time frozen and its length contracted to zero, I am not speculating. I am extrapolating from experimentally verified physics, the same physics that makes your navigation system work. There is a thought experiment that brings this home in human terms. The twin paradox, people call it, though it is not really a paradox at all. Imagine two twins. One stays on Earth. The other gets in a spaceship and flies to a nearby star at 99% of the speed of light, turns around and comes back. The journey takes, say, 10 years as measured by clocks on Earth. But the twin on the ship experiences time dilation with a gamma factor of about 7. The trip that took 10 Earth years takes only about 1.5 years of ship time. The traveling twin ages 1.5 years. The stay-at-home twin ages 10 years. When the traveler returns, the twins are no longer the same age. The traveler is 8.5 years younger than the twin who stayed behind. Not because of some illusion or some error in clocks. Genuinely, physically younger. Fewer heartbeats. Fewer breaths. Fewer cell divisions. Less aging at the molecular level. The traveler's body has experienced less time, and the body knows it. This is not a trick. We have tested the asymmetry with atomic clocks. In 1971, physicists Joseph Hafele and Richard Keating flew cesium atomic clocks on commercial airliners around the world, eastward and westward, and compared them to clocks that stayed on the ground. The differences were exactly what special relativity combined with general relativity for the gravitational effects predicted. Down to the nanosecond. If you traveled at 99.999% of the speed of light for what felt like 1 year to you, you would return to an Earth that had aged over 7,000 years. Everyone you knew would be dust. Civilizations would have risen and fallen. The language people speak would be unrecognizable. You would be a relic from the distant past, perfectly preserved, stepping out of a time machine you built by going fast. That is the cost of speed. Time is the currency, and the exchange rate gets worse the faster you go. Let me ask one more uncomfortable question. What does it actually mean to be you? You are a pattern. An incredibly intricate, staggeringly complex, achingly temporary pattern of atoms. You are not a fixed thing. You are a process. Your atoms are constantly being replaced. The iron in your blood was forged in an exploding star. The calcium in your bones was scattered by a supernova billions of years ago. Those atoms are on loan. They will leave your body and become part of something else. What persists, what makes you you, is not the atoms themselves. It is the pattern, the arrangement, the dynamic, ongoing, never-stopping process of being alive. And that process requires time. It is the one non-negotiable ingredient. Take away time, and the process stops. The pattern freezes. The atoms are all still there in exactly the right positions, but nothing is happening. No signals are being sent. No energy is being transferred. No information is being processed. It is a snapshot, a perfect frozen three-dimensional photograph of a person rocketing through space at the speed of light, and it will remain exactly that snapshot for eternity. Because eternity and an instant are the same thing when time does not exist. Is that person alive? They are not dead in any conventional sense. Nothing has been destroyed. All the information is there. But they are not alive in any conventional sense either, because life is a process, and processes require time. It is like asking whether a painting of a fire is hot. All the visual information about fire is there. But the thing that makes fire fire, the dynamic chemical reaction, the transfer of energy, that is absent. A body at the speed of light has the form of a person without the process of a person, the shape of life without the content of life. Let me close with something I think is beautiful, even though it comes wrapped in strangeness. The speed of light is not just a speed, it is a boundary, the most fundamental boundary in the universe. On one side of that boundary are things with mass, things that experience time, things that change, and age and decay and think and feel and eventually die. Everything you have ever known or loved is on that side. Everything that has ever happened has happened on that side. And on the other side are things without mass. Photons, and gluons, maybe, though they are confined in ways that make the comparison tricky. These things travel at sea. They do not experience time. They do not change. They are born and absorbed in a single instant from their own perspective. They are timeless. And the thing that separates these two categories, the wall between them, is not some physical barrier you could touch or see. It is the structure of space-time itself. It is woven into the geometry of the universe at the most fundamental level. Mass cannot reach C because the mathematics of space-time makes it impossible. The energy required diverges to infinity. Time dilation goes to infinity. Length contraction goes to zero. The universe does not want you to cross that boundary, and it will distort space and time and energy to an infinite degree to keep you on the time-experiencing side. Why? We do not know. We really do not. We know the rules. We know how they work. We can write them down and calculate their consequences with extraordinary precision. But why the speed of light is what it is? Why there is a maximum speed at all? Why the universe is built this way and not some other way? Those questions are open. They may always be open. What I do know is this. Right now, sitting wherever you are, barely moving through space, you are racing through time at very nearly the speed of light. Every heartbeat you feel is a consequence of that temporal velocity. Every thought you form, every memory you lay down, every moment of boredom and confusion and delight, all of it is happening because your space-time speed budget has almost its entire allocation pointed in the time direction. You are not a frozen pattern. You are a burning, changing, evolving process. You are time made flesh. And the only reason you get to be that, the only reason you get to experience anything at all, is that you are not moving fast enough through space to steal your time away. Speed up through space, and you pay for it with time. Speed up more, and you pay more. Push all the way to C, and you have paid everything. Your time is gone, your thickness is gone, your ability to think, to feel, to wonder what happens next, all gone. You are no longer a being, you are a relic, a frozen monument to the person you were the instant before time stopped. I think about that sometimes, not with fear, with a kind of quiet awe, because it means that time is not free. Time is not cheap. Time is not just the backdrop against which things happen. Time is the most precious resource in the universe, and you are spending it right now, just by sitting still, and that is the most ordinary and extraordinary thing I can imagine. The universe could have been built differently. It could have been a place where you can go as fast as you want and time does not care. But it is not built that way. It is built so that speed costs time and time costs speed, and there is a hard limit that nothing can cross. And on this side of that limit, we get to live, we get to age, we get to watch our children grow, we get to wonder about the stars. On the other side, there is none of that, just frozen perfection, hurtling through space at the fastest speed the universe allows, forever and never and all at once. You know, every morning you wake up and your neurons fire, and you feel the weight of blankets and the temperature of the air, and you remember who you are, and you form a plan for the day. That entire experience, from the first drowsy thought to the moment you put your feet on the floor, requires the passage of roughly 30 seconds of time, 30 seconds of biological process, 30 seconds of electrochemical computation, 30 seconds of being on the right side of the light speed boundary. Me, a photon born at the center of the sun, takes something like 100,000 years by our clocks to random walk its way through the solar interior and reach the surface. Then it takes 8 minutes to cross from the sun to the earth. Then it takes a few nanoseconds to pass through the atmosphere and land on your skin. From the photon's perspective, all of that, the 100,000 years inside the sun, the 8-minute journey through space, the passage through the atmosphere, the moment it is absorbed by a molecule in your retina, all of it happens at once. 100,000 years and 8 minutes and a few nanoseconds collapsed into a single instant of zero duration. That photon carries information about the nuclear furnace at the heart of a star, and it delivers that information to your eye, and it does so in no time at all. It is the universe's fastest and most timeless messenger, and the only reason its message means anything, the only reason you can see and think and understand, is that you are made of slow, heavy, time-bound matter that processes the message one step at a time. You are the slow one, and that is the whole point. So the next time someone asks you what time it is, maybe the real answer is it is whatever speed you are not going. What do you think? If you could trade time for speed, creeping asymptotically toward the boundary but never crossing it, how close would you dare to go? Tell me. I am curious.